welcome everyone, and thanks for joining me on this session to learn about EMR Serverless, an exciting new deployment option available on EMR currently in preview. My name is Radhika Ravirala. I am a Principal Product Manager with the Amazon EMR service. I'm glad you're able to join me today. So before I begin this session, a quick show of hands. How many of you are using EMR today? Fantastic. Thanks for using EMR. I hope you like EMR Serverless as well. So here is what we are going to talk about today. So we'll start with what Amazon EMR Serverless is, how it works at a very high level. Then we'll dive into some of the benefits, and we'll look into some of the features of EMR as part of looking at the benefits. We'll also talk about the common usage patterns that we see out in the field for EMR Serverless. I have a short example of how the EMR Serverless works, and then we'll conclude the session by talking about pricing, and I'll be available to answer any questions for you outside the room after this session. So let me begin with the primary motivation for why we built Amazon EMR Serverless. So as many of you know, with EMR on EC2 today, you can provision clusters of any size within minutes. And EMR on EC2 today gives you complete control over how you want to configure your cluster for cost as well as for performance. And that optimizations and that control is desired by a lot of customers. However, there is a segment of customers who are looking for a simpler experience with Amazon EMR. And that's what Amazon EMR Serverless enables. So there were four primary design tenets we thought of while building EMR Serverless. To begin with, it's simplicity. We want EMR Serverless to be simple, which means that you don't have to configure and operate clusters. It is serverless, meaning that there are no servers to manage for you. EMR Serverless automatically provisions, configures, and dynamically scales the compute and memory requirements depending upon your job characteristics and runs the job to completion for you. It is fast because it includes the performance-optimized EMR runtime that you're already familiar with on Amazon EMR on EC2. And because you get the same runtime, your jobs run equally fast. EMR runtime is currently 2 times faster than the standard open source frameworks that you run, such as Spark or Hive. So you get the benefits of the performance optimized runtime with EMR Serverless as well. It's intended to be cost effective, and by cost effective, we mean as you are consuming the resources for your EMR Serverless job, that's the only cost that you will incur, the cost of the resources that you consume for that particular job. EMR Serverless is also going to be comprehensive, meaning that we plan to integrate EMR Serverless with EMR Studio to give you that complete tooling so that you can develop your notebooks, you can visualize, and you can also debug your applications as you are building them. So these were the four primary design goals that we had when we started out on EMR Serverless. Let's take a quick look at how it works. So you have an admin or a user who creates an entity called Amazon EMR Serverless application. And once you have this entity created, your users can start submitting their Spark or Hive jobs. Now, this submission can happen with any of the tools that you are currently using. It could happen using Apache Airflow. It could happen using the managed version of Apache Airflow on AWS. You could use your step functions if you are leaning towards serverless. You can use your EMR Studio notebooks. You can use your other custom data pipelines or orchestrators that you have on your environment today, which includes Control-M or other such orchestration tools. You can also use CLI and SDK to submit these jobs. Once these jobs are submitted to EMR Serverless application, EMR Serverless application automatically provisions workers, and these workers are spun up in the EMR service account. Now, these workers will reach out to resources in the customer or your VPC, which include a Glue Data Catalog if you are interested in using the Glue Data Catalog, an RDS instance if you are using a Hive Metastore on RDS, Secrets Manager to retrieve your secrets, KMS to encrypt your keys, CloudWatch to send your metrics in, and then S3 to store your input and output data. So the workers will have the capability to reach out to these services as they are running your Spark or Hive job. So now that we have seen at a very high level how EMR Serverless works, let's take a look at some of the benefits it offers. So as I mentioned, with EMR Serverless, simplicity was our goal. EMR Serverless is simple because there are fewer decisions to make. You don't have to think about instance types, instance sizes, or cluster sizes anymore. You don't have to configure, optimize, operate, and secure your clusters. You simply choose the open source framework of your choice, whether it is Spark or Hive, and then you pick a version for your Spark and Hive, namely 2.4.8 for Spark if you're interested in that version, or you can pick EMR version 6.5 if you're interested in Spark 3.1.2, and you submit your jobs. So only 2 inputs are needed as a user from you in order to get started. So you don't have to manage patching of your OS, no custom armies to patch whenever there is a new security patch that you need to apply. So the second benefit is, if you are familiar with working with EMR on EC2 today, you spend a good amount of time trying to decide the cluster size. That's because you want to right-size your cluster both for meeting your SLAs to run your Spark job, as well as for cost purposes. With EMR Serverless, there is no need to guess your cluster size. We've implemented something called fine-grained scaling that automatically adds and removes workers at each stage of your data processing job, which means that you don't have to reconfigure your cluster when your data volumes change. So you might have a very spiky workload, you might have a steady workload. Your EMR serverless workers will launch and decommission depending upon your job characteristics. And you're doing this only while paying for the resources that you use. If you're concerned about costs, you can always specify the maximum number of resources that you want your application to use. For example, if you're creating an EMR serverless application and you don't want to exceed 1,000 cores and maybe a few gigabytes of memory, you can specify that while creating your application, and EMR serverless will ensure that it will only scale to that limits. This will keep your costs under your budget. So you're getting all the benefits of running your EMR jobs that you're already familiar with running EMR on EC2 today without managing any clusters. So all the benefits that exist today that you see with EMR on EC2, you get them without having to manage any or operate any of these clusters. One of the benefits of using EMR today is that customers love the cadence that we have with the open source releases. For example, if Spark comes out with 3.5 tomorrow, we have a cadence to release Spark within 60 days of its release in the open source community. So that is one of the primary factors for a lot of customers who want to stay at the cutting edge of running these open source frameworks. So you get the same benefit of keeping in cadence or keeping the currency with the open source community with EMR Serverless. So the new releases will be available within 60 days of its release in the OSS community. As I mentioned a little bit earlier, we implemented something called fine-grained scaling with EMR. As you can see in this picture, if you're running your Spark or Hive jobs, your job is divided into stages. And EMR Serverless automatically determines the number of workers that are needed at each stage of your job. So in this example that you see on the screen, I have 3 stages in my Spark job. The first stage requires 10 workers for 10 minutes. Second stage requires 40 workers for 10 minutes. And the last stage requires only 5 workers for 5 minutes. So with fine-grained scaling, EMR Serverless automatically spins up the required number of workers at each stage of your job, and that will allow you to maintain and lower your cost of running your jobs, because now your workers are only running for the duration of the time they are needed at each stage, and you are only incurring costs for the aggregated vCPU, memory, and storage for the workers during the runtime of in that stage. So we'll add up all the aggregated vCPU, memory, and storage consumption at each stage, and that is the total cost that you'll incur with EMR Serverless. You are charged for this aggregated vCPU, memory, and storage resources from the time a worker starts running your job until it stops, rounded to the nearest second with a 1 minute minimum. That is how the pricing works on EMR. And I'll show you a little more with an example in a later slide. Another important benefit of EMR Serverless is resiliency. As you can imagine, today, EMR on EC2 customers have to plan for AZ failures. If an AZ becomes impaired, or if an AZ is down for some reason, you need to have a plan so that you can launch another EMR on EC2 cluster in a different AZ. So you have a CloudFormation template, or maybe you have a lean EMR on EC2 cluster running in a different AZ or in a different region. Now, with EMR Serverless, resiliency comes out of the box, which means that EMR Serverless is planned as and designed and implemented as a regional service from day one, which means that jobs are automatically distributed to the best availability zone. So when you submit a job to an EMR Serverless application, it is automatically run in a single AZ. And the reason for doing that is to avoid any performance implications of network traffic flowing across AZs. If that AZ becomes impaired for any reason, that job that you have submitted to the AZ is automatically rerun in a different but healthy AZ without you having to do anything. So resiliency comes out of the box, and AZ failures are taken care of, so your jobs run without your intervention in case of such failures very quickly in a different AZ. The sixth benefit that we see with EMR Serverless is enabling you to run secured shared applications. And by that we mean, with each job that you submit to an EMR Serverless application, you can send in an IAM role. And so the benefit of sending an IAM role with each job is that you can restrict the permissions needed for the job, for that specific job, to a specific set of resources that it needs. So a single EMR Serverless application may be able to run multiple concurrent jobs. And these multiple concurrent jobs can each be run with their own specific IAM role. And this will enable simplification of your authorization model, especially in a multi-tenant environment. I'll give you an example of this in a later slide. We'll come back to this. The seventh benefit we see is that for interactive applications. So today, if you're running notebooks, specifically Jupyter notebooks that are run using EMR notebooks, or if you're running EMR Studio notebooks today, you can do that with EMR Serverless as well. As you might be aware, you can today attach your EMR Studio notebook to EMR clusters or EMR on EKS endpoints. When EMR Serverless is GA, you will be able to attach your EMR Studio notebooks to EMR Serverless applications as well. And this will give you an ability to run interactive applications. Now, interactive applications are those which require faster response. For example, you are running a Spark SQL query, or you're running a Hive query, and the user doesn't have time for a cluster to launch. Instead, he wants to see a quick response to your query. So in such cases, EMR Serverless has the ability to start with what we call are the pre-initialized pool of workers. These workers act as a serverless warm pool of workers that are ready to respond to your seconds with a sub-second latency, which means that when you submit a job, the job starts with a sub-second latency on the pre-initialized pool. So these are ideal for interactive applications such as SQL queries and data explorations, which is a common activity for a lot of data scientists and data analysts. And the beauty of running your applications in an interactive manner is that once you're done running your interactive queries, let's say your data analyst or data scientist goes to lunch, the workers are automatically decommissioned once you hit a certain configurable idle timeout. So you can configure an idle timeout for your application to be 10 minutes or 5 minutes or 15 minutes. And after 15 minutes of no active jobs on that application, the application automatically decommissions the workers and application goes into a stopped state. This will allow you to save costs, and you just need to configure the idle timeout, and EMR Serverless will automatically do the job of stopping your workers and the application as well. And finally, we want to make it very easy for you to run EMR applications on any of the deployment options we have available. So today, as you can imagine, you can run your Spark and Hive applications on EMR on EC2, you can run them on EMR Outposts, you can run them on EMR on EKS, and now we have EMR Serverless where you can run the same application. The idea is to be able to run the same application without changing your application code on any one of these deployment options. You should have the flexibility to move to a different deployment option based on your operational needs in future. So as long as the capabilities of your application fit within the deployment option, you should be able to run the same application without changing code on EMR Serverless. The way you submit the job changes. So today, if you're submitting jobs using Spark Submit, or if you're running Step API, calling the Step API to run your jobs, you will be calling EMR Serverless APIs to start your job. That is the only difference. The application code in itself does not change. So with that, let's dive into some core concepts we have introduced with EMR Serverless, beginning with EMR Serverless application. So EMR Serverless application is an entity that comprises of two elements. The first is the OSS framework that you chose, for example, Apache Spark or Apache Hive. And the second is the version that you want to run. For example, if you want to run Spark 3.1.2, then you specify the version as EMR release label 6.5, because that's the highest label, that version that carries 3.1.2. And so these are the only two inputs that we need from you for you to get started on an EMR Serverless application. Now, once this entity called EMR Serverless application is created, you can start submitting multiple jobs in sequence or concurrently or in parallel to this application. Now, in general, one EMR Serverless application should suffice for you to run multiple jobs on it. But there are certain scenarios or use cases where you want to launch multiple applications. And those include scenarios where you want to use a different open source framework. For example, you want to create an EMR Serverless application for your Spark jobs, and you want to create an EMR Serverless application for your Hive jobs. And similarly, if you want to run different versions of the open source framework, if you want to run Spark 3.1.2 and Spark 3.2, then you create two different applications. So these are some scenarios where you want to create different EMR Serverless applications. There are other scenarios, and these are, I think of them as best practices that you already implement with EMR on EC2, which include scenarios when you are performing A/B testing. For example, you are running 3.1.2 today, Spark 3.1.2, and you want to upgrade to 3.2. And so you create a different application with EMR Serverless 3.2 and run your tests on 3.2 as part of your A/B testing, and then you switch over. So that's another scenario where you create a different EMR Serverless application. And then there are other scenarios that you might be familiar with, which include running your dev, prod, and test in different EMR serverless applications. If you want to do cost attributions, cost tracking, usage tracking, all those scenarios will warrant you to create a different EMR serverless applications. Next, we have the concept of a job. A job is nothing but a request made to an EMR serverless that is tracked through completion. You can run multiple jobs on a single EMR serverless application. Each job can be run with a specific IAM role. The jobs themselves are run on workers. Workers is a concept that EMR Serverless uses internally to execute your workloads. So by default, each worker is run with 4 vCPU, 16 GB of RAM, and 20 GB of storage. You have the ability or the flexibility to change the vCPU and memory for your jobs depending upon the requirements. So if your job requires 1 vCPU or 2 vCPUs, you can adjust that while you're running your jobs. And then finally, we have this concept, an optional feature called pre-initialized workers. Pre-initialized workers is an optional feature that lets you pre-initialize workers. What this means is when you create an EMR serverless application, you can submit 2 types of jobs. The first type of job is a batch job, which you're submitting through a pipeline, like, for example, an Airflow orchestrator or a step functions DAG, right? And when you submit jobs through in a batch mode, EMR Serverless spins up the workers required for that job and runs them to completion. Now, once you submit the job, that's when EMR Serverless launches the workers. It takes about 90 seconds to 2 minutes for the workers to come up, and your workers will start executing that job. Now, there is a second option, which is the interactive applications, where you can submit your queries in an interactive fashion. Now, to run those type of jobs, you want to start your EMR Serverless application with an initial capacity. And what that means is you can create an EMR serverless application with a pre-initialized set of workers. Now, once you create an EMR serverless application with pre-initialized workers, this is analogous to having a running EMR cluster, which means that when you submit a job, they are run with a sub-second latency. The request is taken with a sub-second latency, and it is run to completion. Now, this is an optional feature, and I'll talk more about the pre-initialized feature with an example in just a little bit. So now that we have understood the core concepts, let's see how EMR Serverless can be applied to some of the common patterns out there that you are already running today with EMR on EC2. So we'll start with data pipelines. Now, data pipelines are fundamental to many of the analytic workloads. Now, a data pipeline is where you begin launching a cluster, you submit the jobs, and then you terminate the cluster once the jobs are complete. Now, although the steps are seems only three, there is a lot of other things that are being evaluated as this pipeline is run. For example, if you look at the pipeline on the left-hand side, that is the pipeline that you run with EMR on EC2 using Airflow or step functions, where you start your DAG or your directed acyclic graph by determining the instance and the cluster size. So your data engineers spend a good amount of time trying to understand what instance type they should use, what instance size they should use, and what is the cluster size they should use before even they begin launching the cluster. And then they launch the cluster, and then the steps are run, your step API calls are made, and then you terminate the cluster, and that's how your step functions or your Airflow applications run today. Now, this data pipeline is much, much simplified in the EMR serverless world, where you're simply creating an application you're submitting jobs and you're stopping the application, or you have configured the auto stop on your EMR serverless application so that it stops automatically when there are when the jobs are complete, right? So here is an example of how your jobs become simple to run with EMR serverless. So here I have a pipeline with 4 steps, step A, B, C, and D. Now, step A is submitted to an EMR serverless application. Now, EMR serverless determines that it requires 3 workers, and it will spin up 3 workers to run step A. Once step A is completed, your step functions or Airflow is telling EMR serverless that you have 2 more jobs to run, and they can be run in parallel, and EMR serverless takes those jobs, runs them concurrently, and for each job, it spins up the required number of workers. So in this case, step B requires 8 workers and step C requires 10 workers. So it will spin up the required number of workers for both those jobs. And once both step B and C are done, it will run step D as a final step. Now, once step D is run on the 10 workers that it provisioned, your workers are decommissioned once the pipeline is complete. So this is a batch ETL example where you leverage orchestration tools to run your batch workloads. Now, let's take the same example and take it to a multi-tenant environment. So you might be familiar with running shared clusters for teams on premises using yarn queues. So yarn manages the queues for you so that your teams or your projects get the enough amount of resources that they requested. And this is traditionally how customers have managed allocating resources for jobs in a multi-tenant environment. Now, when you move to EMR on EC2, that problem became significantly simpler because now you could run an EMR on EC2 cluster with auto-scaling enabled. You define the business rules and you let the cluster expand and shrink based on your workload characteristics. And we have further simplified that with managed scaling, where the cluster expands and shrinks automatically without you specifying any business rules. We automatically look at some of the metrics for Spark and Hive applications, and we scale the cluster accordingly. Now, you can carry forward the same model, and you will notice that the multi-tenant environment, supporting the multi-tenant environment in an EMR serverless world is even simpler. So you have the same pipelines, same teams, same individuals supporting or submitting jobs to an EMR serverless application, and EMR serverless application automatically provisions the resources required for each of these pipelines or individuals, and up to the maximum limit that you have specified for that application, and runs the jobs. So here is an example of how security is enabled with EMR serverless applications. Now, in a multi-tenant environment, you also need to think about managing permissions, right? You will have multiple teams submitting applications or jobs to the same EMR serverless application, and you want to ensure that these jobs and these pipelines are as isolated as possible from each other. And by that, I mean, when multiple jobs are submitted to the same EMR serverless application, you want to make sure that the workers that are spun up for these jobs and pipelines are not accessing resources required by other pipelines or other individuals. So in this example, as you can see, I have 2 data engineers submitting jobs to the same EMR serverless application. Now, job A is associated, or job A is sent with role A, and role A has access to bucket A and a Redshift cluster A. And so the workers that are spun up to run job A will have access only to S3 bucket A and Redshift cluster A and CloudWatch group A. And these jobs are submitted at the same time, and the workers are spun up at the same time. But you will notice that the job B is run with a completely different set of permissions, and that has access to a completely different set of resources. So as you can see from this example, your workers are isolated from each other, and your job permissions can be isolated from each other, and you can run your serverless applications, EMR applications with EMR serverless in a much more simpler format than you are used to on EMR on EC2 today. Another aspect of running Spark and Hive jobs is having that ability to debug your jobs. For example, you want to be able to debug your jobs as the job is running, also when the job completes, which means that you will have the ability to spin up Spark UI, the live UI, when the job is running. And you will also have the ability to run a persistent UI, the history server, once the job is completed. So you will be able to launch the history server and look at the jobs that have already completed, even if you have terminated the application. So job debugging and logging is further simplified with EMR Serverless. So the third pattern that we see out there in the field is interactive applications. And these are applications where customers are running Presto queries or Spark SQL queries or Hive queries on their EMR clusters. So here is an example of how that would work on EMR Serverless. So just like in the previous example, I have an EMR serverless application running. The only difference is I have created this EMR serverless application with an initial capacity of 10 workers. So as you can see, I have 10 workers that are in the stopped state. Now, the minute I submit a job to this application, or I make an API call to start the application, the workers get into a ready state, and this is when you can start running your jobs. So in this example, I submitted job A, which requires 3 workers. Now, this job A is run on 3 workers taken from the pre-initialized pool. So the pre-initialized pool will be used to run job A. Now, if you submit job B now that requires 7 workers, again, this job B will be run on 7 workers from the pre-initialized pool. So now, if you submit additional jobs, for example, in this case, job C, now the pre-initialized pool of workers are busy running job A and job B. At this time, EMR Serverless automatically spins up additional workers to run job C. Now, once all the jobs are finished, as you will notice, the workers that are spun up for job C are now decommissioned, and you are left with the pre-initialized pool that are ready to take on your next set of jobs. Now, if you have a next set of jobs, you can keep submitting jobs to this application. But if you don't submit any job and you have set your idle timeout to be 5 minutes, after 5 minutes, these workers will be decommissioned automatically. Or if you have not set up an idle timeout, you can manually also call an API to stop the workers and stop the application. And that's how you can save on costs once your jobs are complete. So observability is another important aspect of running your big data workloads. So as you are running your Hive and Spark applications, logs are continuously pushed to S3. And these are the event logs, the container logs, your application logs are pushed to S3. Event logs are what are used to power your Spark UI and history server. And you'll also be able to look at the service level metrics for your application and job through CloudWatch by GA. So you'll have visibility into your metrics, as well as monitoring capabilities for your EMR serverless application. So let me walk you through an example. So I've done a few demos. You can find them on YouTube. If you just type EMR serverless demo, we have some Hive as well as Spark examples. They have been run at various events. So today I want you to walk you through a simple example of how the experience is if you are running an EMR serverless through CLI. So let's start with creating an application. So creating an application is fairly straightforward. All I need is two elements. One is the name of the OSS framework, which is the type Spark, and the last one, which is the release label. Now, I can optionally name my EMR serverless application. I have named it here, and I can optionally also set up an auto stop configuration. So here, the default idle timeout is 15 minutes, but you can set it up to a different time if you wish to do so. So in this example, I set out an idle timeout to be 20 minutes. Now, auto start is automatically configured, so which means that it's enabled by default. So this application will automatically start on your first job submission. But if you want to start the application through an API call, you can do that as well. Now, this is an easy way to start creating an EMR serverless application, and this is the getting started experience for you. If you today want to try EMR serverless application, this is the easiest way to get started. Now, let's say you have tried some few examples with EMR serverless applications, you've built some of them, and now you want to explore some other features that are available. For example, you're interested in figuring out how to specify my driver count. How many drivers do I want? How many executors do I want for my EMR serverless job? How can I specify the maximum capacity for my EMR serverless? Now, you can do that very easily, as you can see in this example. So I can specify the initial capacity for my EMR serverless application. I can be very specific and say I want so many drivers, I want so many executors. I can also specify how many vCPUs and memory I want for each of my driver and executor workers. And I can also specify the maximum capacity or the maximum number of resources that I'm allowing my users to launch with this application. So it's fairly straightforward and very easy to do with EMR serverless. And then once you define or create your EMR serverless application, the next step is just submitting the jobs. And submitting jobs is also a simple API call. You simply specify the application ID to which you want to submit. And then you can specify your IAM role. As I mentioned, IAM roles are critical. Because they give you the flexibility to define the permissions that your job will have. For example, an S3 bucket or a Redshift table. And then you can specify the parameters that you want to pass to your Spark submit. For example, if you're sending in Spark submit today, parameters to your Spark submit job today, you will be able to do the same thing with your EMR serverless jobs. You can also have configuration overrides. Now, this is very helpful when you want to override some of the configuration that Spark and Hive provides. So for example, if you want to modify some parameters, like if you have an external Hive metastore and you want to specify the name of your Hive metastore, the RDS instance that you're using, you can override that information in the configuration overrides section of EMR serverless start job API call. So here in this example, I'm showing how you can specify the monitoring configuration where I'm indicating the S3 location where I want my S3 logs to go. So with that, let's dive a little bit into pricing. So here is an example of how pricing works with EMR serverless. As I mentioned earlier, EMR serverless jobs are divided into stages, and at each stage, EMR serverless launches a set of workers that are required to complete that step, and we aggregate the compute memory and disk across those workers for the runtime of those workers during that stage. And we do this across all the stages, and that is the cost that you will incur at the end of running that job. So the pricing is simpler. It's along 3 dimensions: your vCPU hour, your amount of memory that you have consumed, and the total storage per hour. 20 GB of storage is ephemeral storage is available for you for free. Anything beyond that is what you will incur the cost for. So EMR Serverless is currently in preview, and you have the ability to run Spark and Hive jobs with using AWS CLI, APIs, or SDK today. You can pre-provision workers to start your job immediately. You can set up the auto stop of idle applications. You can configure that, and you can also configure the auto start of applications upon job submission. So all these features are available for you to try out during the preview time. And there are plenty of resources for you to get started with. For example, we have a blog that outlines everything that I've spoken just now in greater detail. We also have a preview sign-up page. If you're interested, please sign up for our EMR Serverless. Your account will be allow listed within a couple days, and you can start running your existing Spark and Hive jobs on EMR Serverless. We have a good number of samples available in a Git repo, and we also have extensive documentation available for you to get started. So that is a quick overview of EMR Serverless. I'm very happy to take your questions now.